Before we get into the technical content, I would like you to go and watch these two videos. The first one talk about the applications of different communication technologies, and the other one present a use case. The whole point of watching this video is to convince you that there is no one technology fits all. It is important to pick the right communication technology for the right job depending on your IoT system and the application domain. Each of these technologies has its own pros and cons. Please pause this video and watch the two videos I have put here. When you are designing an IoT system, you should consider all the communication protocol options. However, depending on the domain, we can allocate some of the communication technologies as the most likely choice. However, this doesn't mean that you can't change anything, but based on what people use commonly, this table summarizes what are the communication technologies that each of the domains commonly use. Please pause this video and study the table. Typically, an IoT system comprises with sensors, actuators, and a control unit. Both sensors and actuators need to talk to the controller that may be on premises or somewhere in the remote place. So communication need to take place in between these components. We use different types of protocols in multiple layers to make this communication happens. Moving data from one place to the other we consider as data communication. So you can see a sample data communication figure in this illustration. In this figure you can see there are sensors communicating with a Wi-Fi router using Bluetooth and Wi-Fi, and then use mobile communication to communicate with the mobile tower, and then data sent to the cloud to do the processing, and then commands come back. Here I am going to introduce you to a couple of terms that come across in this network communication domain. First one is home network. Home network is referred to a home or office where you connect different computers and peripherals together, probably using copper cables or wireless communication. These are local area networks independent from the internet, managed as a local network. When you want to access internet, then you need to use a router and connect these local area networks to internet. Through the routers, these local area networks become part of the internet. However, all the communication directly need to go through the router. Direct communication is not possible because within the local area network you have local IP addresses which is unknown to internet. This is what we call networks of networks, which is the backbone of internet. There are three key components in a simple network: devices, media, and services. So devices are basically computers, printers, routers, and servers, and any other IoT device. Medium is the cabling. It could be copper cables, fiber optic, or even wireless communication without cables. And then the services are the software that support operations such as email hosting, video streaming, or any other service. Among the three key components, the devices and services are pretty much developed by us or the developers. However, the middle one, the media, there are a number of choices we have to make, but it is not up to us to develop any media by ourselves. So we have to pick the media based on four criteria: the distance a signal needs to travel, the environment it is traveling, the amount of data and the speed of the data, and the cost of media and the installation. So these are the four criteria that we need to evaluate when you are picking a media for your IoT system. Computer networking is a very broad subject. In this lesson or even in this course, my objective is not to teach you computer networking. However, to understand some of the networking requirements in IoT context, you need to know a little bit of how the internet and packet routing works. So I have put 2 videos here where they talk about data routing. Please pause this video and go and watch these 2 videos to better understand how the internet works and how the data routing works. Because the fundamental knowledge about data routing is quite important to understand IoT data communication. This is a very important illustration where it shows different types of network communication technologies and some of the concepts. So please spend some time to understand this illustration fully. On the right hand side, we can see PAN, LAN, MAN and WAN corresponding to personal area network, local area network, metropolitan area network and the wide area network. Each of these network types are standardized by standardization organizations. So 802.15, 0.11, 0.16 and 0.20. So these are the standards that focus on governing the standardization process. Within each of these categories, there are sub-categories and sub-standardizations. As depicted in the illustration, the blue color, the personal area networks, are pretty much the communication around us. Basically, it is within our reach, within the limit, most likely within the home. So wearable and smart home IoT devices probably will be using personal area network technologies. The local area network is pretty much Ethernet and Wi-Fi, which we use in homes and offices to provide the backbone communication. The metropolitan area network is where high-speed network deployed in cities. So they are connecting either the small city or it could connect a few different buildings or blocks together with high-speed internet. And then wide area network is pretty much the entire large cities or from cities to entire world. For each type of these networks, PAN, LAN, MAN and WAN, there are corresponding communication technologies, very specific implementations developed by different people. So there are power lines, Ethernet, which are pretty much focusing on local area networking. Then we have RFID and NFC, near field communication. These are tracking technologies, very small amount of data, but very short range, useful for PAN. Then we have 6LoWPAN, Zigbee, Z-Wave, UWB and Bluetooth. These are personal area network technologies used for smart home as well as for wearables. Then we have the Wi-Fi for a local area network. Then we have technologies like DAS7, WiMAX, weightless, more like a metropolitan area networking. And then after that 2G, 3G, cellular, satellite, LTE, all these things are wide area networks. Then within the wide area network category, there are also up and coming low power wide area, which is LoRaWAN, Sigfox, NB-IoT. Those are also wide area networks, even though they are not mentioned in this figure. This figure classifies communication technologies we discussed earlier based on the range. So RFID, NFC, and then QR codes you probably have seen are near field communication less than 10 centimeters. And then the personal area network is about 1 meter to 50 meters. It is important to note that the distance or the range what we present here or anywhere is not exact numbers. They are basically to give you some idea, but there's no definition saying that what is the exact range that can be used to represent these different types of networks such as PAN, LAN, and WAN. There's no consensus among the community about the range. Every source that you will be looking will have some similar range, but it most likely will not be the exact same. So personal area network would be like 1 to 50 meters, Bluetooth, Zigbee, Z-Wave, 802.15.4 family of protocols. Then the local area network, especially the Wi-Fi ones, Wi-Fi could be from 50 meters to 1 kilometer based on what kind of repeaters we are using. Then above 1 kilometer, it could be considered as wide area network. You have the technologies like 2G, 3G, 4G, 5G, low power wide area networks such as LoRaWAN, Sigfox, NB-IoT. So these are the wireless communication technologies classified into 4 different areas based on the range. Let me now go through the classes of different networks one by one. So first one is the most common one, which is wired or wireless local area networks. We call it LAN or WLAN for wireless. These are one of the first networking technologies or categories where people used to connect homes, offices, campuses, and networks within them. So they're basically connected to the internet using a router, as you can see in the image. And then each of the devices within the network has a local IP address which cannot be directly communicate with the internet. It has to go through the router. Typically, local area networks provide high bandwidth connectivity. And from IoT perspective, wireless LAN are the common use in homes and offices these days. If you have any IoT devices, you will be connecting to Wi-Fi. But computers may be connected to the local area network using Ethernet cables. The next common one is personal area networks, or we call PAN. PAN usually wireless. Usually we don't distinguish WPAN separately because by definition personal area networks were wireless in comparison to local area networks, where the local area networks were established as wired technology, especially the Ethernet. The wireless came much later, so we specifically talk about LAN and WLAN. But here the PAN and WPAN you might not hear as frequently because they are pretty much from the inception they were supposed to be wireless. But there is a new variation where low power wireless personal area networks, which called low PAN. Especially there are upcoming standards on 6 low PANs. We will be talking about it later at some point in this lesson. But personal area networks traditionally Bluetooth is the one that we use most commonly, all the wearable devices. So this is an interesting figure where we have listed personal area network based IoT devices. Please note that some of the products we mentioned here may be not in the market by the time you watch this video, because the products come and go depending on the economic viability. But if you go and search each of these terms, you might see some of the videos or some kind of traces of what they have been doing. They are interesting because there are a lot of different categories, and some of the categories you might be not thinking before. So I would suggest you to pause this video and go through these terms. Go and search on these product names and study what kind of IoT products people have been developing and what are the functionalities and purposes on them. It is also important to note that most of the personal area network IoT products usually use mobile phone as a gateway. In comparison to the in smart homes, in local area networks, they use the internet router as the gateway. Wide area network is the next networking category, which aims to cover large geographical areas such as cities, from cities to entire globe. Within that wide area network, recently there has been movement towards low power wide area network. We will be discussing some of the technologies later on. The idea is to develop a low power, low packet size, wide area networks which people can use to communicate small number of messages each day at a low cost. Because when you are communicating across large geographical areas like cities or even jungles, you might not have direct access to the power. You might need to, depending on batteries, or harvest energy. Because of that, the low power is a significant importance when it comes to wide area communication. In this graph, you can see each of the communication technologies are positioned against bandwidth and range. So if you want to pick a particular technology for your IoT system, then you can decide by looking at the range of the system that you're building as well as the bandwidth requirements. Please study this figure to understand what are your options. Out of the variety of different network communication technologies we introduced earlier in this lesson, these are the technologies that we are going to discuss a little bit in detail over the remaining lesson. We will be talking about RFID and NFC under the near field communication. Then under the personal area network, we'll be talking about Bluetooth, Zigbee, and under the wide area network, we'll be talking about LoRaWAN. We have selected the mostly commonly used technology under each category, but this is not the exhaustive list. Every day there could be new technologies, communication technologies coming into the marketplace, and sometimes some of them get adopted over the others. Some of the standards get disappeared. So these are just a few representative technologies that you might want to think about. These will act as a pointers, and then whatever the new technology comes in, you can easily understand them because they are at least familiar with one of these technologies.